The given matrix is A is equals to 6, 10, minus 2, minus 3. Now we have to find the trace of A power 10. Now first of all, let us see a property. If A is any matrix whose eigenvalues are lambda 1, lambda 2, lambda 3 and so on. Now then trace of A power n will be nothing but sum of all the eigenvalues raised to the power of n. So lambda 2 power n plus lambda 3 power n plus so on. Now in order to find the trace of A power 10, first we have to find the eigenvalues of A. Now in order to find the eigenvalues, we'll consider 6 minus lambda 10 minus 2 minus 3 minus lambda is equals to 0, which is nothing but the characteristic equation. If we simplify this, we'll get lambda minus 2 into lambda minus 1 is equals to 0, which is nothing but lambda 1 is equals to 1 and lambda 2 is equals to 2. That is, the eigenvalues are 1 and 2. Now according to the property, trace of A power 10 will be lambda 1 power 10 plus lambda 2 power 10, which is 1 power 10 plus 2 power 10. That is nothing but 1025. Option D. It is given that a coin is tossed 4 times. We have to find the probability of getting exactly 3 heads. Now we'll solve this problem by using binomial distribution. Now here the total number of times a coin tossed, that is n, is given as 4, and we need the required probability, that is getting heads thrice. So r is equals to 3, and x is nothing but the probability of success. Success is nothing but getting a head, which is 1 by 2, and y is nothing but the probability of getting a failure, which is again 1 by 2. Now we need p of x is equals to 3, which is given by the formula ncr into x to the power of r into y power n minus r. Now we know the value of n, which is 4, then c3, x is nothing but half cube into 1 by 2, 4 minus 3. If we simplify, then the value will be by 4, which is nothing but option A.
Okay, in this question he has given induction type meter. Maximum torque is obtained when one of the parameters of the rotating disc is. Okay, now what is torque of induction motor? It is directly proportional to some cos phi. Okay, now what is phi here? Phi is equal to tan inverse of x by r. Okay, if x is equal to 0, phi is equal to 0, what happens to cos phi? Cos phi is 1. Now where the maximum torque will occur in induction type meter when x is equal to 0, that is option C.
Here the question is, find out Vc in the circuit shown below when the transistor is in active region and Vb is given as 0.7 volts, right? So here he is asking for voltage Vc, that is from this collector point, this point 2 and this ground. Then generally this is a ground, right? So for this, first we have to find out. So if we apply a KVL equation in this loop, so what we'll get, here VB is given as 0.7 volts, this is 0.7 volts. If you apply a KVL equation, so I'm applying a KVL equation here, minus 4 volts plus 0.7 plus, suppose let us take this current is IE, because this is an emitter, that's why I'm indicating this current as an IE. Okay, and what will get 0.7 plus 4k multiplied by IE equal to 0. So from this what we will get for IE? IE equaled 4 minus 0.7 by 4k. 4 minus 0.7 by 4k, and this is equal to around 0.825 milliamperes, right? So we got IE. So we know that IC is approximately equal to IE. So that's why the current here also, this is IC, and this is same as IE. So this current is now 0.825 milliamperes. Now he is asking for the voltage between this point and this point, that is VC. So VC is nothing but VCC minus 5k multiplied by IC. Now if you solve this, we will get IC equal to 3.9 volts. So the option is B here. Is find out the maximum sine wave output voltage at 2 MHz frequency if the op amp slew rate is 10 volts per microseconds, right? So this is a direct question. So we know that the formula for slew rate, that is delta equal to, generally we will indicate slew rate by delta, and equal 2 phi f times the Vmax, where Vmax is generally output voltage of an op amp, right? So if you solve this, Vmax equal delta by 2 phi f. So this is 10 by 4 pi, and if you solve this, we will get approximate value is the approximate value of this is around. So approximate value of this is around 0.8 volts. So obviously option will be A. So we have to go for option A.
In sequential circuit, the output at any instant. Okay. In combination circuit, if you see, the output depends only on present inputs because it doesn't have any storage for the outputs. Okay. In sequential circuits, you have memory, so it output depends on past outputs and present inputs. Option is